Hello, everyone. My name is Kevin Son. I'm from Princeton Blockchain Society, and I am extremely excited to be leading this lesson, which is the introduction to the open web. Essentially, in this presentation, we're just going to go over the basics of blockchain technology, so why we need it, what it is, how it works, and the implications and the future for blockchain technology. And so it's okay if you don't know anything about blockchain technology. Hopefully by the end, we'll have a much better understanding. So first, I think it's important for blockchain technology to kind of go over the whys. Why do we need blockchain technology? What happened within our society that led to this point in which blockchain technology became such an important part to every industry of the world? So I think the main point, as in my opinion goes, is as the world gets more digitized, and we know it will, the importance of data security and data privacy rises. So as we depend more and more on, for example, Instagram or Facebook to share our data, we have to understand that whenever we use these technologies, we're really not we're giving away our ownership of data without really specifying the rules in which they can use it, right? And we know, for example, Facebook has been known to be using our data maybe without our consent or without even acknowledging that they are. And so as we put more and more of our personal information out there in the world, and as we continue to use these new technologies, I think it's very, very important that we find a way so that we can keep ownership of our data. And more importantly, we can ensure that our data remains secure, right? And whether it was intentional or not, we know that many companies are prone to being hacked, right? Twitter, Facebook, etc. And so even if it's not due to bad intentions, we know that they're capable of being hacked, which only really hurts the individuals that use these companies, right? When we use Facebook, we're basically relying on them to store our data and not be hacked. And we sort of have no control over that. And more importantly, in financial systems, for example, in banks, whenever we use a bank, we're really relying on the security of the bank, right? We think we own the money, but in reality, the bank is really just holding our money for us. And let's say a bank would disappear just instantly overnight, well, our money would be gone, right? We wouldn't really have any way to control over what we really own. And this problem became extremely exemplified in 2008 during the 2008 financial crisis. And I think this was the moment, a really shift towards blockchain technology, because this was when people realized that we can't really trust banks, right? And we really can't trust centralization. And this led to an anonymous person by the name of Satoshi Nakamoto publish his white paper about Bitcoin, which really was a new financial system that relied on blockchain technology that removed the need for a third-party system. So it made us able to use a financial system in which we can send and receive money in the form of a cryptocurrency called Bitcoin without the need for a centralized bank. And it really started to shift this idea of maybe we don't need to rely on centralized systems like Facebook or like banks to hold our data and hold our personal information. Maybe we can automate the system, decentralize the system, so that we can trust the system, know that it's secure, but also be able to own what we truly own, our own privacy, our own data. And there is a kind of a second side of why we should care about blockchain society. There is also a very clear financial incentive. We've seen in recent years the boom of cryptocurrencies, the boom of NFTs. These are all related to blockchain technology. We'll learn that they're not equivalent to blockchain technology, but they use blockchain technology. And so because blockchain technology is an innovative, sort of relatively new field of study, it makes sense for a lot of people to get into the space for
Hey, Kevin, you muted yourself. Yep.
Sorry. There is an incentive for people to get into this space because there are this availability of new exciting projects to be built on the blockchain space. Okay, so that's just a little bit of why we should care about blockchain society, blockchain technology, and why it became a thing, essentially. So I think next, we're just going to talk about what is a blockchain. And when you search up a definition of blockchain on the internet, we see something pretty technical like this. A blockchain is a digitally distributed, decentralized public ledger that exists across a network, right? And it's okay if you don't know what any of these words mean. Hopefully by the end, we'll come back to this definition and we'll break it down in ways we can understand. So I'm going to be using a widget from a man named Anders Brownworth. And this is a helpful widget. You guys can go back to it on your own if you want. I think it really helps understand and break down the blockchain from what it is in the very beginning. And so we have to start with something called the SHA-256 hash. And so this is a cryptographic function, which means that it's a mathematical function. It takes in a data. The data can be a string of any length. It's not limited to a certain length. And it encodes it into a hash. So if I change the data up here, you can see the hash down here is the output of the SHA-256 algorithm, right? And there's a couple important things about the SHA-256 hash that makes it critical for the blockchain to work. So for one, it cannot be reversed, meaning that if you know the hash or the output, you cannot kind of reverse the algorithm to find the data. And that's really important. Also, the second important thing is that it's almost collision-free. So what that means is the odds of two data inputs having the same output is incredibly small. It's not zero because of the fact that the hash is actually limited in terms of how long it could be. It's always a 256-bit string, which converts to 64 characters, right? So it's always going to be 64 characters long. And since, like I said before, the data can be how long as it wants to be, right? There's a clear, there's a larger domain than the range that it gets outputted to. So it is certainly possible that two data points have the same hash. But the probability of that being so is incredibly small just because the hash can have up to 2 to the power of 256 possibilities, right? Since it is 256 bits. Okay, and so that's all the SHA-256 hash is. It's a function that takes in a data point and outputs a 256-bit hash, and it cannot be reversed. And if there's any questions, sorry, I should have mentioned this before. If you guys have any questions, please put it in the chat and I can address them. Okay, I'm just gonna, okay. So now we move on to the block. So a block in a blockchain really is a set of data. So it starts with the block number, which is sort of like the index of the block. We'll see this being relevant later. The nonce, it stands for number once, which basically is another argument that we attach to our data. And we'll see why this is important in a little bit. The data, which is the same data field as before, and the hash, right? And so we're still using the SHA-256 algorithm. And we notice that right now the block is green, and green just in this widget just means that it's verified. And basically what we're trying to do is we're trying to verify or mine a block. And we call a block verified if its hash begins with 4 zeros. In the case of Bitcoin, this number of zeros may change. It depends on the blockchain. In this widget, it just so happens that that it's coded to be verified when we have 4 zeros. And so the important part of this is, let's say I wanted to mine a block where the data, let's say, is Kevin, right? You'll see that it turned to red because the hash doesn't begin with 4 zeros. Well, we want to figure out a way to run the SHA-256 algorithm to get a string, a hash that begins with 4 zeros while not changing the data. And this is where the nonce comes in, right? The nonce is an extra argument that's kind of attached to our data, combined together, and then put into the SHA-256 algorithm. And so you can see the nonce is just a number, but as we change the nonce, the hash also changes, right? And so mining a block is really only changing the nonce, figuring out which nonce reveals the hash that begins with 4 zeros. And that's really what computers are doing when we talk about mining a block, right? It's really a brute forcing, checking which nonce makes the correct hash. And because of the fact that SHA-256 cannot be reversed, the best way to do this is really only to brute force check every nonce until we get the hash that it wants, right? And so this is why it's so important that the SHA-256 can't be reversed. If it could be reversed, and by the way, studies have shown that even quantum computers can't reverse this function. The reasons for that is it's a lot of mathematical rigorousness that we won't cover here, but because it can't be reversed, imagine it could be reversed. What would happen? Well, then computers would just be able to figure out which nonce value makes the hash verifiable at a quicker rate, which means that they'll be able to mine it quicker. And we'll see later that every time a computer mines a block, they're given a small reward, right? And so that's kind of their financial incentive for mining a block. And so it's really, really important that the cryptographic function that the blockchain relies on cannot be reversible for that reason. And this little button right here, the mine button, we'll see what happens. Right now, the nonce is 726. It will change to something else. Right now, it's checking the nonce values right here. 43,382 just so happened to be the nonce that attached with the data field Kevin revealed the hash that starts with 4 zeros, right? So now the block is verified. Does that make sense for everyone?
Yeah, I think we have one question in the chat.
Okay. So Matthew, I'll start with his question first. How is it that a hash can't be reversed if hash contains data that is eventually decoded? Doesn't that mean there's a solution somewhere that can be used to crack the hash? Right. So this is a really cool, important question. The answer lies in the algorithm itself. So if you look up SHA-256, the actual algorithm is incredibly complex, and it's a mathematical function that has a property that it means that it can't be reversed. For reasons that are obvious, we won't go over the actual algorithm here. It has to do with a lot of number theory and a lot of different mathematical functions. Katya, what is the reason for needing to guess the hash? Can't we just get the hash and get on with it? Well, the reason for having to guess the hash is because we can't ensure that the data itself will begin with 4 zeros, right? If I just put in Kevin, the hash may not begin with 4 zeros, which means that the block won't be verified. So that's why we need this extra argument in which we add on to our data field, and then we can use that argument to basically verify the block, if that makes sense. Pranay said, are miners only trying to guess the nonce? Right, so in actual blockchains, this system of mining is a little bit more complex, but for the purposes of this demo, that's essentially what they're doing. They're basically solving this cryptographic puzzles, in which case it's just kind of guessing the nonce in order to get the verifiable hash. So yeah, why not start every hash with 0000? Well, the hash isn't something we can control. The hash is the output, remember, of the hash function, right? So it's a mathematical function, right? So whenever we put in a data, it outputs a hash. And so we can't really control what the hash is. Okay, cool. All right, if there's no more questions, I'm going to move up. Can there be multiple nonces that satisfy our requirements? Yes, but really all that matters is finding a nonce that works. And so really, it doesn't matter what the exact number is as long as the block is verified. And the first one that basically is found is the one that becomes the nonce that verifies the block. And yes, that's a good point. The number of zeros at the front of the hash signifies the difficulty of mining. So obviously, if you need more zeros in front of your hash, it's going to be more difficult to mine the block, right? For Bitcoin, I believe this number is 19 different zeros. So in order to verify a block of, or mine a block of Bitcoin, you have to have a hash that begins with 19 zeros. It's different for every blockchain. And this is sort of how Bitcoin, for example, makes it harder and harder to mine a block in the future. They increase the number of zeros that you need to have in your hash function. They started with a very small number and increased it gradually. Okay, so I'm going to now move on to a blockchain. So a blockchain is now just a chain of blocks, right? So you can see this is where the block number becomes important. It's just signifying the number, the index of the block within this array. Okay, and as you can see, all of these blocks are green, which means like that the blockchain itself is verified because all of its individual blocks are verified. But we'll see that we have one more argument, which is this previous hash, right? And so this is how the blocks in our blockchain are chained together. you'll see that, for example, the previous hash of block number 2 is equal to the hash of block number 2 is equal to, for example, the hash of the previous of block number 3, and so on. So we can see this as kind of being chained together. Okay, and the reason why this is important is, let's say, for example, in block number 2, I changed the data. Obviously, what will happen is the block that it's in, block number 2, will become unverified, because remember, it changes the hash, right? So now the hash is changed. It doesn't begin with 4 zeros, and so it's unverified. But more importantly, every single block after it is also unverified, because, for example, block number 3 has this previous hash of block number 2 in it, which changed. And so the overall hash of its block also changed, right? Because now for each block, the SHA-256 algorithm not only inputs the nonce and the data, they also input the hash of the block before it, right? So this is kind of a symbolic way of chaining all of our blocks together, because now it ensures that whenever we change the data in a block, not only will its block be unverified, but every single block after it, right? And so you can imagine, how would we fix this problem? How would we remine this blockchain so that it becomes verified? Well, if we mine this block number 2, again, we changed the nonce so that its hash starts with 4 zeros. Well, notice that it didn't verify the blocks after it. And that's because now that the hash begins with 4 zeros, it doesn't necessarily guarantee that the next hash, block number 3, combined with the hash that begins with 4 zeros, the previous hash, the data it has and the nonce it has, it doesn't guarantee that the new hash is going to start with 4 zeros either, right? So to mine the entire blockchain, you would have to mine every single block in this chain, right? And this is sort of the reason why a blockchain is so secure. Let's say that our blockchain currently contains the data fields of something. Let's say they contain the data of transactions, right? And let's say some malicious hacker wanted to go into the blockchain and change the history of the blockchain, and say that Bob gave Kevin 500 Bitcoin, right? If he wanted to put this into the blockchain, right, he would have to mine every single block, including itself and after it, all within the time before the next block is added, right? Because remember, this ledger, this blockchain, blocks are being added to this chain continuously. In Bitcoin, it takes around 10 minutes to mine a block. Ethereum takes 14 seconds, right? Every blockchain is different, but even 10 minutes is not enough time in order to mine this block, then mine every single block after it and pretend that nothing changed, right? And more importantly, adding on to that level of security, we move on to this distributed blockchain, which is really what a full blockchain is. We have the same copy of the blockchain with different peers. In this case, we have 3 peers, but each peer, you can think of it as a computer that's mining the blockchain. There's going to be thousands of these in the case of Bitcoin, right? Let's say I wanted to change the data in block 2, again, all within 10 minutes, I would have to mine this block and every block after it in this chain. But even if I do that, even if I am able to successfully mine it, so let's say, just for the sake of time, I change this data, I would mine this block. And then after this becomes verified, I would have to mine block number 5. As you can see, it already takes a bit of time. You'll notice that because of the fact that everyone has a copy of the blockchain, so this one's mine, let's mine this one. Because everyone contains the same copy of the blockchain, what will happen inevitably is they'll notice that the hash function of the last block, in this case, the one I changed, and ended with 769, whereas everyone else's ended with 67C. And so the way that a consensus works in the blockchain peer distributed way is that the majority of the blockchains have to agree on a version before they add it to the blockchain. And so in this case, even if I were able to mine every single block in this changed version that will benefit me, because it doesn't agree with the majority of the other copies, it will be rejected, right? And so how would I successfully hack it? Well, I would have to do this to over 50% of the versions in the network. And this is called a 51% attack. Basically, a group of hackers would need to be able to control over half of the computers, half of the copies that exists in the world, and they would have to be able to change all of them within the time it takes to add another block, right? And so that is incredibly, incredibly difficult to do, which is why we say that the security of blockchain is so good, right? It's so very, very, very hard in order to hack a blockchain, just because of the fact that the more people that are mining your blockchain, right, it makes it harder for the individual or a malicious group of hackers to be able to change what's already written. And that's why we say it's immutable. Okay. I'm going to take some time to read some questions because I feel like it has been quite a bit. If I understand correctly, you are explaining the proof of work consensus mechanism. Yes. So every blockchain sort of has a different consensus mechanism. In this case, we're basically going over how Bitcoin works, which uses something called proof of work. Maybe in later lectures, we'll learn proof of stake, which is how Ethereum works, and more different consensus mechanisms. But this is the main one, proof of work, and this is the one that Bitcoin used. Okay, cool. So lastly, we have to understand what is the incentive for miners, right? Because of the security of the blockchain relies on these computers mining and competing to see who finds the nonce first, right? There needs to be a reason for them to do so. If there's no reason for them to do so, right, they can all just stop mining the blockchain, and therefore the blockchain wouldn't work, right? And so to do that, we realized that what we can do is we can add an incentive. And so this is kind of like the full form of what a blockchain does, is it utilizes a cryptocurrency. So now we can see the difference between blockchain technology and cryptocurrency. Notice that in terms of blockchain technology, the data field inside the data didn't necessarily have to be transactions, right? In the case of Bitcoin and in the case of financial systems, this data will be transactions, but we could use a blockchain to record just about anything, right? And we see cases, for example, if you wanted to record other things like supply chain issues, right? Where let's say a certain meat moved from farm to farm, we can record this on a blockchain, right? And so it doesn't really need to be financial transactions, which separates kind of blockchain from cryptocurrencies in a way. But the reason why we need cryptocurrencies is because what we do is, let's say we're working on Bitcoin, for example, every miner, whenever they are able to mine a block successfully, first, we give a small amount of Bitcoin to them as a reward. And so this is really the incentive for them to be mining the blockchain, right? They receive some sort of currency. It's a digital currency, right? Defined by the blockchain. But the idea is, as the blockchain is more used, the value of that cryptocurrency increases, which increases the incentive for these miners to mine the blockchain. And we see this happening with Bitcoin today, right? Bitcoin as a blockchain is sort of separate from Bitcoin as the cryptocurrency. Same with Ethereum. The value of Bitcoin is incredibly high, which incentivizes miners to mine Bitcoin, which allows its blockchain to function, right? So it's a really nice cycle of things that allows the security of it to be maintained. Okay, so that's sort of the bit about blockchains and how it works. I'll stop for a little bit to answer any questions if you guys have any questions. But hopefully this kind of visual example helped us understand basically how blockchain works. So does anyone have any questions? Okay, well, you can continue to write questions in the chat and I'll stop as they come in. But that is basically it for the blockchain demo. It's the amount mined dynamic, right? So whenever you mine a block, you like we said, we get a small block reward. In the case of Bitcoin, and the reason why I keep saying in the case of Bitcoin, it's because every blockchain, every cryptocurrency works in a different way for a different reason. But for Bitcoin's purpose, the amount that you get, the block reward that we get, decreases over time. And the reason for that is because Bitcoin's max supply of Bitcoin is limited. It's capped to, I think, around 21 million Bitcoin, right? So there will come a point in which all of the Bitcoin that is able to be mined is zero, basically, right? There's no more Bitcoin to be created. And so there's no more Bitcoin to be given to the miners. right? But in that case, when that happens, they'll have another incentive, which is a small transaction fee. So whenever you make a transaction, a small amount will go to the miners that mine that block. But this is the case of Bitcoin. It's different for every blockchain. But yes, in the case of Bitcoin, the amount that you get for the block rewards does decrease. Powell said, what happens to the other 49% of people that say don't agree? Well, the blockchain moves on. As long as the majority of the people agree on a version of the blockchain, that's the block that's added. And it might seem concerning, but imagine we have more and more people in the network, right? To be able to get 50% of people or miners to agree on something is incredibly difficult, right? Are you only able to see the hashes of blocks? How are you able to access the data if it's used as a method of storage? So as someone that, let's say, is working on the blockchain, right? Like we said before, everything is publicized. It's a publicized ledger. And so we are able to see the data, but it's all hashed, as we said before, right? So it's all kind of secured in this way that even if I say I give you $50 in Bitcoin, it will be kind of cryptographically secured so that someone else won't essentially be able to see the contents of like who did what. We'll learn this, I think, in the second lecture when we talk about account models and how that works in particular. Santa asked, not sure whether it's a good question, but can the authorities control over 50% of the computers? So the cool thing about blockchain and Bitcoin is that there really is no authorities, right? There's no administration. There's really only users of a blockchain. There's really no administration. And the code that Bitcoin runs on today is the same code that it ran on in 2008. It's an open source code. You can literally search it up. You can run it on your own computer. That's sort of the transparency that makes blockchain so powerful, right? And so there's really no authority that's able to change the code or be able to control certain computers. It's really individuals that are using kind of the financial incentive to mine and run the code that Bitcoin runs on. If that makes sense. There's no more questions. Okay, I'll move on. So we'll go back to this definition of a blockchain, right? A blockchain is a digitally distributed, decentralized public ledger that exists across a network. And let's see if we can unpack this now. So first, it's digitally distributed. Like I said, it's a digital code, essentially, and it's run on different computers. It's decentralized. Notice that we didn't rely on one bank or one kind of document such that everyone puts their transactions on there. Rather, it's decentralized in the way that everyone contains a copy and everyone kind of contributes towards the security of it, right? So now to rely on the security of a blockchain, we're relying on the millions, thousands of miners rather than just that one entity in the case of a bank or in the case of Facebook or whatever. It's a public ledger, which means that everyone contains the copy of the blockchain, as we said before. And lastly, it exists across a network, right? All of these computers are connected in a way that they're all competing across the network to be able to add the next block. Okay, so do we have any questions? How can, if at all, a government stop people mining? What if they say it's now illegal in their country? Right, so this actually has been a growing concern in cryptocurrencies because of this whole idea of like regulations, right? The idea of blockchain is supposed to be sort of this decentralized method, but there is this underlying pressure from basically energy laws, right? So in the case of Bitcoin, for example, it uses proof of work, this system that we just outlined. It relies on miners being able to calculate and figure out the next nonce. Well, that relies on heavy computing power, right? And so what has been a problem is governments have been concerned with, well, as more and more people try to mine the block, it's only going to incentivize them to use more and more energy, which is bad for the environment. And this is sort of a controversial issue. There are people that say, well, sure, it uses a lot of energy, but compared to like the amount of energy we use elsewhere, it's really not a big deal. So this is a growing concern. But this is definitely something to look out for, government regulations of blockchain. And I think this is a current issue. I think we're currently seeing a lot of senators and a lot of our government in America talk about how to regulate cryptocurrencies, as well as other places in the world. I know, for example, China, they place a lot of regulations on Bitcoin mining, which ironically sort of helped Bitcoin's blockchain, because before a lot of the mining power used to be in China, but after these kind of bans and regulations, it kind of forced it to spread out elsewhere, which kind of helped the network, obviously, because you don't want, let's say 50% of it to be in one city. It becomes easier to hack it, right? But I think what we'll see happen is, as let's say regulations are imposed, the miners will just move to areas where it's easier to mine, right? And obviously we can't regulate every single place on Earth, right? And so I think blockchain as a whole, because it's so popular, it's gained traction today. It's not a huge deal, but we are seeing this problem today. And yes, as Troy mentioned in the chat, the ban in China actually resulted in more decentralized mining pools. Yeah. Okay. But does this definition of a blockchain hopefully make sense now to everyone? We understand what it means for it to be decentralized, public ledger, and so on. Okay. So then, now that we know what a blockchain is, I wanted to take some time to talk about what we call the 3 generations of blockchain. So how blockchain emerged. We talked about that in the form of Bitcoin, but also how it changed into what it is today. Because if you see cryptocurrencies or blockchains today, it's being used for a lot more than just the purpose of moving transactions from one place to another, right? So the 3 stages of generations of blockchain, this is actually kind of a definition set by Near. I think you can find it a more in-depth article on Near. But they define open money, the first generation, as basically Bitcoin, right? It utilized blockchain to allow for a digital version of money, which allowed us to have transactions that are faster and more secure, right? And so this is basically what we just defined, what we just talked about, how Bitcoin works. Okay, and the next generation of blockchain is open finance. Now, open finance differs from open money because it allows us to kind of interact with the cryptocurrency that the blockchain holds, right? So in the case of Bitcoin, really all we can use Bitcoin for is what it was built to do, is as a form of currency. But other blockchains like Ethereum was sort of the pioneer of open finance. It allows developers, so coders, to actually write programs on top of the blockchain. And they did this by essentially building a virtual machine on top of the blockchain. And so these programs, we call them smart contracts. And basically we can write automated serverless scripts that are basically ran automatically through the blockchain. And it allows us to use the token in more creative ways. And this is a quote I took from Near. It says, "Money is no longer a store of value or transactional asset. It can now be operated on useful ways which multiply its potential." So for example, we can create projects on top of the Ethereum blockchain that utilizes the Ethereum token through the use of these smart contracts. And by the way, the actual way we do this is definitely going to be talked about in future lessons. But just know that this is the concept of open finance. It allows us to write programs on the blockchain, which is a huge step forward from the limitations that we had before in the case of blockchain, in the case of Bitcoin, right? And Ethereum, for example, is the first blockchain that enabled us to do so. And the key point to know with Ethereum is, in order to do this, right, in order to be able to process huge projects that use smart contracts continuously, we need to have a platform that's fast enough to do so. And also the transaction cost, the cost to run a program on a blockchain, has to be low enough for these huge projects to exist, right? And so it needs to have speed and cheap transactions costs, which Ethereum was able to do. It created, like I said before, a fully functional virtual machine on top of basically what Bitcoin was. And it utilizes Ether or ETH. So ETH is different from Ethereum. Ethereum just is the name of the blockchain. ETH is now the name, or Ether is the name of the token that's utilized by Ethereum. And so if you go on a cryptocurrency market, right, you'll see Ether, not Ethereum. And this is sort of that distinguishment, right? So Ethereum represents a platform in which developers can now create projects on them. There are several famous ones already. Compound is a money lending platform on Ethereum. So for example, if you want to, it's like how a bank works, right? If you want to loan money with an interest rate, you can do it through Compound. The difference between Compound and a bank is Compound is fully decentralized. It exists on the blockchain. And so there's no centralization like a bank. And the interest rates are automated. DAI is what we call a stable coin that was built on top of Ethereum. A stable coin is basically a cryptocurrency that's pegged to a real asset, like a US dollar. And lastly, Uniswap is a more recent development. It's a project on the Ethereum blockchain, which we call it a decentralized exchange or a DEX. So it allows you to exchange different cryptocurrencies for a different cryptocurrency on the Ethereum blockchain. And these are just several examples of projects that became incredibly famous and successful. And this was all due to the fact that Ethereum allowed us to now create these programs on top of the blockchain. And so this is kind of a huge development from open money into open finance. What's the difference between token and cryptocurrency? I've seen these used interchangeably. Are they different? Right, so I think Troy answered this well. Cryptocurrencies are referring to fungible tokens. Tokens could be referring to fungible or non-fungible tokens. This is really just a technical definition. But in the case of what we're seeing right now, token and cryptocurrency can be used for the same thing. If you deep dive into the technical differences, they are slightly different, but it doesn't make a difference in the case of this presentation and our knowledge of blockchain so far. Okay, so this is open finance. It allows us to now build projects, programs on top of the blockchain. And these programs are run through the blockchain, so we know it's secure and it's decentralized. And this brings us to the open web. So the open web and open finance is very, very similar, right? It still uses the smart contracts that we talked about before. The only real difference is the open web now expands beyond just finance, right? As we saw before, open finance really were just projects that were centered around financial needs. What developers realize is blockchain, like I said before, doesn't need to only take in things that represent finance, right? And in fact, anything that holds value can be tokenized in the open web, right? Money in open finance was literally just a line of data that we said hold value. And so what the open web is aiming to do is now create these projects that take blockchain beyond just the financial world, create projects that can be applied to all industries, and create projects that allow for more interactions with the user. So the way I like to think about this is kind of analogous towards the development of the internet, right? We had one-way systems like PayPal and things like that. But later on, we saw the development of things like Instagram, Facebook, these social media platforms where users were able to interact with the internet in a higher way and allowed us to use the internet in a more complex way. And this is sort of the analogy in blockchain terms, what the open web is trying to do. Here's another quote. Just like Ethereum enabled the easy piping of high value money, any asset that can be tokenized can be piped through a similar set of components, right? So basically it allows us to kind of tokenize anything that holds value in the real world and allows us to interact with it. Okay, and the same challenges in the open web exist as they existed in the open finance when we went from open money to open finance, in that in order to process the different cases of the open web. So when we have the open web, these projects are going to be much, much larger. It's going to require more data, more transactions, and more usability. And so existing blockchains sort of need to be able to support higher volume, higher speed, lower transaction costs, and this other argument, which is more usability, which means that it needs to be able to enable interactions between the blockchain more efficiently and better. And so these are sort of the challenges that are ongoing today. How do we create a blockchain platform that supports all of these? And it's one that Near, the focus of this web series, is aiming to solve. Near is another blockchain platform, and it's aiming to solve these scalability issues and in order to make a platform that can be used for open web projects in the future. And now I'm going to introduce Cameron, who is a member of the Near ecosystem, who can better explain how Near works and how important it is for the future of blockchain technology. So Cameron.
Hey, Kevin, thank you so much for this awesome presentation. And hey, everybody, my name is Cameron Dennis. I work at the Near Foundation. I've been here for about a year and a half, mainly working on everything ecosystem related. This includes grants, dev shops, investor relations, essentially keeping my pulse on the finger, keeping my finger on the pulse of the ecosystem, making sure that projects get the support that they need and whatnot. But yeah, to dive kind of right into it, actually, do you mind just going back to I believe it's the original slide, SM class platform? Perfect. Yes. So what Near is, it's a layer 1 blockchain that is focused on empowering people to own their assets, control their data, and participate in governance for all the platforms in which they use. The key issue here is that, blockchains are really hard to use. How many of you have actually tried to actually have a MetaMask and, or better yet, in the chat, who here has lost their keys before? Like their actual private key to their wallets, because I have, and it's not a good time. You lose everything in there. And so what Near is really focused on is bringing blockchains to billions of people. And right now, Ethereum, although I love Ethereum and I got originally involved in 2016, this was definitely the thing that powered all of this, it's not fast enough. It's not usable enough, and it's too expensive for mass adoption. And so this is why I ended up working at Near, because that actually solves all these problems very tangibly. And if you don't mind just clicking next slide, we can get into what we're actually focusing on. It's really about the creators, the communities, and finance. So for creators, how do we actually empower people to own the assets and sell them that they create, to pretty much have new revenue streams to monetize? And then communities, how can you actually participate in the governance of these communities, so your voice is actually heard compared to these Web2 platforms in which you don't benefit from. And then open finance is really this job of a market maker. So market making, for those who might not know, is something that's been around since the beginning of finance. This is the primary role, or one of the roles, of Goldman Sachs and BlackRock and these sometimes even trillion-dollar organizations, or they have trillions of dollars of assets under management. Their job is to create the market for people to buy and sell assets. Now, what blockchains sort of revolutionized here was the fact that now they're giving that power to the everyday people who might want to participate in providing what we call liquidity for the market. And this is where anyone can participate, primarily on these decentralized exchanges as what we call market makers. And I'm happy to dive into that a little bit later, but you can click next slide. Try one more. Yeah, so Near can scale to billions of users because it's actually super inexpensive to use. It takes, it's about fractions of a penny per transaction. And every wallet on Near is human readable. So what that means is my wallet ID compared to Ethereum, which is be 0x, yada, 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 I'm Cameron.Near. And this makes it so much easier to socialize this as if it's a Venmo username or an email address, rather than a long string that you would have to copy and paste to me for me to understand or know. And so that's why we're focused on simplicity, secure, protocol's never gone down, billions of dollars at stake, making sure it continues to be secure, and then scalable. This is through what we call a sharded architecture. And what that means is we're essentially, anytime that more transactions come to the network, then the blockchain actually creates these sort of sub blockchains, what we call shards. And I'm simplifying this. I'm happy to send you those who are interested more information on the actual details of the architecture. But this is how we're able to maintain 100,000 transactions per second with 1 second block finality, which means the blockchain actually gets essentially verified every single second. And then also, yeah, tiny transaction fees, fractions of a penny. So next slide. Yep, so right now we launched sharding, which is a really huge deal in computer science generally. This is the architecture that Ethereum 2.0 is looking to adopt. There has been a little bit of a pivot in the ETH2 roadmap, more focusing on zero knowledge tech in order to scale. But we actually, and part of that reason is because it's really hard to deploy sharding, actually upgrade a system with billions of dollars in value locked into it. To go through a major upgrade takes a lot of time and a lot of due diligence. So we had the Near Foundation, Near Inc., and the rest of the ecosystem had a much easier time building this because we didn't have all that technical debt. So we launched sharding on mainnet, which is super cool. And no difference at all to developers. What's really cool about Near as well is that, and if you actually click next slide, you should be able to see a little graphic about it. Near is completely Ethereum compatible. So if you have contracts that are deployed on Ethereum today, you can deploy them on Near and benefit from the low fees and high speeds and everything. And you can write contracts in Solidity, which is the primary language for Ethereum. The next thing is a native ecosystem, which is all written in Rust and assembly script. For those who don't know what Rust is, it's another programming language that's what we call like lower level, closer to the actual metal of the computer, where you can write essentially more secure contracts, and there's less room to mess up, because there's a huge concern, and you may have seen this in the news, where there's a huge hack that over hundreds of millions of dollars or dozens of millions of dollars gets exploited. This is the caveat about having everything on chain, is that there are significant risks with and liability that lies in these smart contracts. And Rust is a much sort of better programming language to write these contracts in. It's harder to learn. So that's also why we support something called assembly script. It's essentially extension of TypeScript, which is a programming language that most web developers in the world know today. And this is really compelling because this means we can onboard thousands, if not hundreds of thousands more developers into the Near ecosystem than other ecosystems, because we already support Rust, assembly script, Solidity, and also now substrate-based chains. So everything that is being deployed on Polkadot today can also just be deployed right away on Near through something called the Octopus network. And this is very similar to the Cosmos ecosystem as well as Polkadot, because people are able to deploy their own app chains. And what an app chain is its own blockchain in which you're able to set the parameters, and how consensus is created and how many validators you stand up. It's essentially your own private chain if you want it. And to me, this is the beginning of an open web that works for everybody. Why? Because it's flexible and it provides people the choice, provides people the option to write contracts in Solidity, deploy on Ethereum, deploy on Near, Polkadot, and everything can interoperate with Near. What's also really compelling about Octopus is the people who launch their own app chains, they don't have to stand up their own validator set, their own miner set, because they can just leverage Nears. And that's really compelling, because if you're a founder, you should be focused on building a good product and growing to billions of users. Maybe it's not the best use of your time to deal with protocol politics and all of this technical infrastructure that's a little bit, it's cumbersome. It's a lot of overhead. So the goal with Near is, how do we abstract all of that away for the developers to seamlessly just build apps and deploy? And so if you go to the next slide, you should see this. Yeah, interoperability. That's kind of what I was getting at before. But what really powers this as well is all these bridges. And so if you're relatively new to the blockchain ecosystem, you'll start learning that there's all of these bridges in between these different ecosystems where you can move assets from Bitcoin to Ethereum, and Ethereum to Near, Near to Polygon to Solana, all this stuff. Now, there's sort of I think of an issue with all of this, mainly because these bridges are probably the largest targets. They're the largest security and vulnerabilities in the space, mainly because when you're moving assets, let's say from Bitcoin to Ethereum, what you're really doing is you have some contract that you're depositing, some program that you're depositing your Bitcoin into, and then running some sort of verifier saying, hey, these coins have been locked in this contract. Let's recreate those tokens on this other blockchain one-to-one. So one Bitcoin on Bitcoin goes in the contract, another one on Ethereum gets created. And if the Bitcoin gets destroyed in the Bitcoin contract, then it's also destroyed on Ethereum. Now, that sounds pretty straightforward and cool. The issue is that there's a lot of centralization within that process. And so what's really cool about the Rainbow Bridge is it's not completely decentralized, but it's permissionless. So you're able to take it and fork it and do whatever you want with it. And there's a clear path towards creating a decentralized bridging architecture. And that's a really powerful thing. And that's what's really going to enable interoperability across all these different ecosystems. And so right now that Rainbow Bridge is possible on, it's deployed between Ethereum and Near. And so that means you can move your assets between these two chains very seamlessly, as long as you have a Near wallet and an Ethereum wallet. So I'm just going to drop the link to the bridge in the chat here. Check it out yourself if you're interested. And also, I would highly recommend, if anyone is interested in getting a Near wallet, you can direct message me on Twitter or on Telegram at Cameron Dennis, and I'm happy to send you a little bit of Near just to kind of get started. So next slide. Is there a next slide? No?
I'm not sure if there is a next slide.
Okay, well, in that case, we do have 7 minutes left. I can keep on going on, but I think it might be best to answer some questions if there are any. Cross-chain transactions again. Yeah, so show a demo of the Rainbow Bridge. Yeah, I could do both. So let me just change my wallet address. So yeah, so cross-chain bridging. You essentially, there's two models. There's like a burn and mint. So you create an asset on one chain, what we call is running like a light client. And what that really is doing is just ensuring that data on one chain is the same as data on the other chain, or one contract is the same as the other contract. And there's sort of an issue here with, there's sort of an issue here because of that centralization risk. There was a big hack, it's called Wormhole. It was a bridge between Solana and Ethereum, and there's $300 million plus lost. I think it was the largest hack in history, actually. I think it's the largest amount of money stolen at once. And this is why it's such a concern. We haven't seen all of this play out quite yet, but yeah, I hope that explains. There are other chains do what Near is doing as well. Who are your main competitors? So yeah, there are some. I would say the largest competitors of Near are Avalanche, Solana, Terra, Polygon maybe, but really it's about the different architectures. So Near is what we call the sharded blockchain. And the reason why I like that, why I like sharding, is because it can scale forever. And it, at the core of it, has decentralization baked into it. And why that's the case is because every time more demand comes to the network, you need more shards. And with more shards comes more validators. And there's this huge queue of validators that it's just ready to deploy onto the network. So the users don't even have to really think about it. The goal is to abstract blockchains away from end users. Blockchains, to be honest, they kind of suck. They are super hard to use for average, for like normal users. They're confusing. And so the goal is to create the open web as seamless as, with an experience as seamless as debit cards. When you swipe a debit card, you don't really know that the transaction is moving through 3 different payment providers and there's the Swift network and all this stuff. Retail users should not have to know what blockchains are. So how do we abstract all of this away? Well, the answer is with account models. So how transactions and accounts are actually maintained on the blockchains can serve as the infrastructure to start abstracting the complexities away. And on Near, every wallet is a smart contract. And why that's important is because we can start now creating these new models of experience where you can, let's say, associate your Twitter account with your public key, and with your blockchain wallet. So now you can even log into a Web3 app using your Twitter handle or using your Discord or Instagram or whatever it is, like login. It's like essentially Web2 authentication. And that to me was one of the most compelling things. I'm also the president and founder of the Blockchain Acceleration Foundation, a 501c3 nonprofit that helped put this all together. And I've worked with all these other chains. We've gotten grants, we've built curriculum. And the reason why I work at Near is because it's just designed to scale to billions. And this is the point of, to me, the open web. So yeah, let's see, is Near using dank sharding? Close, it's called Nightshade. And I'm happy to drop the link in the chat, just a link to the paper. And this is, if you're interested in learning more about how distributed consensus works, this is how the Near does it. Wormhole V2 later this year. I couldn't speak to that. Wish I could. Transaction costs. Actually found out transaction fees for cross-chain bridging is actually hard as Near tackle that issue. So Near tackles the issue on the Near side of things. It is impossible for us to decrease the price of gas on Ethereum. So when you're moving assets from blockchain to blockchain, you actually have to rely on the gas costs on the chains in which you're bridging to. So on Near, it's fractions of a penny, super straightforward. And that would be between like Near and any Near affiliated application, or which would also be like Aurora or Octopus. Aurora, by the way, is the EVM, Ethereum virtual machine of Near. So that's where you're able to use Ethereum applications. Oct Network is actually based on Substrate. Yes, it is. Short answer. And what is the next steps into DeFi? So first step is creating a wallet. That wallet is, you can go to wallet.near.org. I'm also, if you message me on Telegram or Twitter, I could just send you a wallet directly with some Near inside for you to get started. And the best way to get going is either participating in Ref Finance. That's the primary like decentralized exchange on Near. And if you want to, you could even bridge assets over into the Ethereum land through the Rainbow Bridge and start participating on anything in ETH land, or also I would avoid starting DeFi on Ethereum. I actually do recommend using every blockchain. Like what's really cool about Near is that it's a great starting point for people to get into any other ecosystem as well, because we're compatible. And so that is the EVM side of things is through an application called Aurora, and happy to chat more or like tell you more about it if you're down. What is your take on the progress of the blockchain industry? Do you think we need L1 wars to end before we see major? Yeah, I would love for the L1 wars to end. This is like, I'm actually kind of sick. I don't really want to be promoting Near. In a perfect world, I'd be promoting the applications built on top of Near. I see Near long-term as like HTTPS. Like it is what is securing, verifying all the security of our URLs that we're using, but it's there, it uses to verify, but no one really cares about it. It's like, it's not the thing. Really what we should be promoting are the applications building on top of Near. So the NFT marketplaces like Paris and Drawstring and others, or the DAO frameworks, this is to me, where the value lies. The layer one is just it's really just infrastructure, and ideally no one should really have to know about it, but we're still in the stages today where it matters. Eventually it won't. The time will come. So I do see here, there is 640 nodes online right now. Why are there only, so there are two types of nodes. There are validating nodes, and there are, like, I guess just like general nodes. General nodes sign transactions, and it doesn't require you to actually have like a validator set, like actually have. So the way it works is that to run a validator, you actually have to have a minimum stake of 100,000 near. And that's kind of high. It's about $1 million. Similar to Ethereum, how you have to have 32 ETH to run one. And the reason for this is because it's a proof of stake network. Kevin did an amazing job explaining proof of work, but proof of stake is a little bit different, where you are being, the thing that's securing the protocol is actually the money being staked into it, because there's all these economic incentives for you to validate proper transactions in a proper way, where you don't get slashed if you provide, if you do any sort of illicit activity, or like, that your node goes down. So there's a little bit of a difference. If you click the I, actually, I'll just drop the docs here in the chat. What is a node here? What is a node? What is node, and then what is a validator? I'm dropping here if you're interested in learning more. And yeah, it looks like those are most of the questions. Oh, wait, great session is possible. Yeah, so it is possible for people to change go from Solidity to Rust. It does take some onboarding experience. So what really impressed me about Near in the early days was their focus on developer experience. And so we have a ton of educational content. This sort of your web series is just like the tip of the iceberg. We have amazing grant programs, in your university programs. It's all self-paced. Once you become a Near certified developer, you could even start getting placed at jobs within the ecosystem. And we're essentially created this like giant machine because of talent and opportunity, because we're building a new economy here. We need marketers and community managers and developers and front-end developers and like everything, accountants and lawyers. So we're in this early days. Everyone on this call is still incredibly early. So what I would highly recommend you doing, if you're down to learn more, definitely come next week. We have a huge, just amazing agenda for you to dive into all of these different use cases more tangibly, and start participating. I think that's the very best way. So DM me on Twitter or Telegram. @ Cameron Dennis is my Telegram. And on Twitter, it's just Cameron_Dennis. And I'm happy to send you a link to a Near wallet. Now, what's really cool about this link I'm sending you is I'm creating a sub account under my main account, and we're going to dive into accounts and transactions in another session. But the really cool thing is I'm just giving you access to claim a sub account that deletes my access. And I know that sounds kind of basic and boring, but why this is so important, it's such an amazing onboarding tool to bring in, let's say, all of Beyonce's fans into Web3, because there's no way that they're going to use a MetaMask wallet. It's going to give them just the option to claim their NFT and participate in DeFi, rather than, hey, in order to get started with this platform, you have to create a wallet and remember your seed phrase or write it down. So yeah, let's see. Huge problem with EVM compatible chains is that to deploy a Trader Joe or Benki, the apps need to be completely written from Rust to Solidity. Is that necessary on Near? So it's not necessary for you to have to rewrite all your contracts from Solidity to Rust or Rust to Solidity. And that's why Aurora, if you have contracts, programs written in Solidity, you can just deploy them. And there is even an amazing grant program to give people the funding just to kind of like get it, like figure it out. Like, hey, here's $10,000 to figure out how to deploy your contracts to Near, and for you to support, future adoption or maintenance, really. And so I can honestly ramble on about Near for hours. But if you guys want to hear about anything specific, happy to chat. Can't be messaged on Twitter. That is a good point. I should probably change that. And so, yeah, next session, Alexis, do you want to come back on, or Taran, just talk a little bit more about like the workshop series and what people can expect in future sessions?
Yeah, I guess I can give a brief outro. Thanks everyone for joining today. Cameron and Kevin, you guys did an amazing job. Thank you so much. Yeah, so the whole series of workshops is going to be 10 workshops distributed between 10 university blockchain clubs and BAF. BAF is great. It is based out of America. It's a non-profit charity for accelerating blockchain education and blockchain-based initiatives. And yeah, tune in next week to hear me, Imtiaz, Alex, and Mihal from the Cambridge team to hear about to hear about an introduction to blockchain development. Really, we'll go over different consensus mechanisms. We'll go over just an overview of cryptography of your blockchains, and it'll be carried on by multiple sessions every week. They'll happen all on the same time, on the same day, Saturday at 5 p.m. GMT. And yeah, that's about it. It's great to see lots of university clubs working together, and I really like the structure of organizing a series of workshops. It's great from the students' end because all of us are volunteers at our university clubs, so hosting a series of 10 workshops would be a lot of work for just one club. It's a lot of commitment. And secondly, from the audience perspective, you get to hear from students all around the world, and students also get experience in learning first and then teaching it. So it's great. That's really all I have to say. Follow BAF on Twitter, and also make sure you join the Discord. The Discord is great. It has that's where you'll receive most of the updates, and you can also talk to each other on there, which we highly encourage. Everyone should be talking to each other, collaborating, and it'd be good for next time if you guys play around and maybe try to set up a Near wallet. Also, there's the Near website has loads of amazing videos that you can watch in the meantime. They're very they are very inclusive, and they're quite easy to grasp. So I highly recommend those. There's loads of tutorials on YouTube as well, and this series is more or less to give an overview, to give you a kickstart into development on Near. I guess it's for me. I want to give myself a kickstart into developing on Near in the summer. So this kind of ties me down into learning Rust and so on. So yeah, thanks all for coming, and that's basically it. I'll leave it to Alexis to sort of close us off, if he's still here.
Yes, I'm still here. I think you summarized everything well. So thank you everyone for coming. Don't forget to join the Near Web Series Discord. We are all there. You can send message, ask question. We have office hours there too. So office hour information. So just check it out. Join us on the well, see you next week, same time, same Zoom link, and we will invite you on Google Calendar.